Good day. So once again, this is your teacher friendly. So I'm back. I have decided to create a short review of what we have discussed for Mathematics 10 of the third quarter. So since you will be answering your summative test, so I just want to make sure that you do have a guide. So for those who have already forgotten what those topics are, so don't you worry, I have summarized everything in the simplest way. So we have only taken up permutations and combinations, right? And we have differentiated the two from one another, what is permutation and what is combination. And also we have illustrated both in three different methods. So how do you illustrate permutations in three methods is also the same as how you illustrate combinations in those three methods. And also we have solved problems involving permutations and combinations. So let's start the ball rolling. Again, grade 10 students, I hope this helps you a lot. So let's start what is permutation. So just remember that permutation and combinations, both of them are part of, this was called as branch of mathematics before, combinatorics, and this requires the skill, the basic fundamental skill. So I'm always incorporating activities that would help you develop this what we call as FCP, or fundamental counting principle. Again, what is fundamental counting principle? It states there in your module that if there are P ways to do one thing and there are Q ways to do another thing, and you want to get the total number of possible ways wherein you can do both things. So all you have to do is get the product of those, right? And also, just take note that permutations and combinations, they both refer to the group of objects in a set or elements in a set. So when we say permutation, the only difference is that the order, all right? So if the order does matter, then that is permutations. If the order doesn't matter, then that is what we call combinations. So how can we tell that the order matters in a particular situation? All right, so I have cited an example. Like for example, once again, if you can still remember our MELC 1 module for illustrating permutation, I have cited there an example that requires the order of the given elements in a set or the objects in a set. Like your Facebook password. If I set up my Facebook password as ABC123 star, alright, and I want to log back in, although I can remember all of those 7 characters, but I cannot put there, or I cannot rearrange those characters like 1, 2, 3, ABC, and star. It will never work, right? Because that system requires you to enter those characters on the same order upon creating that password from the very beginning. And another thing is very obvious, like a padlock of your ball. You purchase a padlock that has numerical code 1, 2, 3, 4. Although you would like to use the same digits to unlock it, it will never work by typing in 4, 3, 2, 1 because the order matters. So that's what you need to remember when we talk about permutation. The order matters. What about if I have given you a project and this is the group of 5? I assign you as the leader, so basically, being the leader, you will be the one to look for your members. Alright, so let's say you have picked 4 of your group mates as part of your team. You are the leader, and you pick Sarah, Kyla, Jenny, and Mark. Well, the question is, does it make any difference if you pick first Mark, followed by Sarah, Kyla, and Jenny? Or if you choose Kyla, followed by Sarah, Jenny, and Mark? No, right? It doesn't make any difference because they are still the same person in a group that you have selected as your teammates would be. So that is what we call combinations. So basically, permutations and combinations are closely related to each other It's just that the order the only differs from the order, right? So if the order is being emphasized, like no numbers can be repeated in a group of combination of 2 or 3, then order matters. If you're being asked the characters on your Google account password, if you can rearrange that one, so no, right? Because the order does matter. Let's cite an example to make it clear so we can differentiate permutations from combinations. You have read from your Milk for Mojo how to differentiate or the clue words being used to define situations that involves combination. And that
Combination has a clue word that uses the word selection, choose, pick, and combination.
Have a clear example. Let's say, for example, Jenny places 3 oranges, 4 apples, 2 bananas. In how many?
The question is, in how many ways can the children pick 6 fruits from the basket? So please try to analyze the question. In how many ways can the children pick 6 fruits from the basket?
6 fruits was not specified whether 5 apples and 1 banana or 3 oranges and 3 apples. The problem don't care about the order. It's just that what was asked are the figures 6. So as long as the children pick 6 fruits, the question is in how many ways can the children pick 6 fruits? The 6 fruits can be composed of any number of those 3 kinds of fruits. It can be 3 apples, 3 bananas, 2 apples, 2 bananas, and 2 oranges. It doesn't matter. So the order doesn't matter in that particular situation. So that is combination. But if you are being asked on how many 3-digit numbers can be formed from the digits 0, 1, 2, 3, 4, and 5. If no number or no repetition is allowed, so that means if you have combined 0, 1, 2 as your first 3-digit combination from the digits 0 to 5, you cannot use 0, 1 to rearrange the numbers into like 210 or 210 as your second combination because no repetition is allowed. So no repetition is allowed, that means the order is important, so that is permutation. So those are just common scenarios wherein you can differentiate permutations from combinations. Now let's go back to illustrating those two in 3 methods. Illustrating permutation is the same as how you illustrate combination. What matters or what? Illustrating permutations is the same as you are illustrating combinations. So permutations can be illustrated through listing method, tree diagram, and its formula. Formula for permutation, n factorial over n minus r factorial. And you know what factorial means, right? And how to expand it. And for illustrating combination is actually being illustrated through those 3 methods. Listing method, tree diagram, and as well as its formula. Formula for combination is n factorial over n minus r factorial times r factorial. So we just added r factorial in there. So they are closely related. Now, if you will be solving problems involving permutations and combinations, you might find somehow tricky if you don't understand the terms or what is being asked. Like for example, in permutation, whenever you see the word ranked, arrangement, like for example in arrays wherein there is a rank like first, second, and third, so that means the order is being emphasized. So you know that when the order matters, it is permutation. Well, if the order doesn't matter or otherwise, that is combination. So if you know how to understand and interpret the given questions enclosed in a problem, then you would be able to answer whether it's a combination or permutation. Now, for the formula of permutation, we have applied 4 different formulas in there, so don't be confused. Just understand the problem. Like for example, in the word kind, wherein we apply the first formula for permutation that says permutations of n objects taken all at a time. So if we have the word kind, we got 4 letters or 4 characters in it, K-I-N-D. And if you will be asked in how many ways can you arrange these 4 letters, so that means everything will be part of it, like K-I-N-D. So you won't be leaving any letters aside because you will be taking the same number, which is 4. So it is clear that your formula for that kind of scenario would be just n factorial. What is n factorial? So again, if you take out of 4, like for example, we have 4 people, and you would like to arrange that 4 people.
So you would like to know in how many ways can you passively arrange those people in 4 chairs.
So if we have positioned the first person, or let's say the 4th person, since all of the 4 seats are vacant, he has 4 options to choose from out of those 4 chairs. He can sit on the first chair, he can sit on the second chair, on the 3rd chair, or on the 4th chair. So we put there 4 because that person has 4 options left. And once that person already pick a seat, so there will be 3 remaining chairs out of 4. Now the 3 remaining people, the 3rd people will be choosing either of those 3. Since there are 3 spaces or 3 vacant chairs, that 3rd person can arrange herself or himself in 3 different ways. So we got 4 times 3. And then we got 2 remaining people left with 2 chairs left. The second person would have 2 choices left out of those 2 chairs. So you can sit on the 3rd chair or on the 4th chair. Once he positions himself, there will be only 1 vacant left and only 1 person left. So the last person will be sitting on the last chair. That's why we have n factorial, which is 4 times 3 times 2 times 1 for that given scenario. Now, for the formula of permutations taken all at a time, just write down or substitute the number of objects or elements in the set for your n and expand it. Then you will have your answer, permutations of n objects taken all at a time. Now for the second one, which is very easy as well, permutations of n objects taken are at a time. So you have to determine your n, which is very easy. Just count the number of objects, whether it's people, group, or numbers or characters in a set. That will be your n. How many would you like to take? If you have 10 classmates and you would like to take a photo of 2 or by pair, so your r is 2 and the n is 10, because they will be grouping themselves by pairs, so it's automatically 2 since it's pair. So if that is the case, that you will be taking permutations of n objects taken r at a time, there's a specific number wherein your r should not be greater than n, then you will be using the formula n factorial over n minus r factorial. So all you have to do is substitute the figures into your n and r, then solve. Simplify your expression. Then you will get your answer. Or you may use a calculator if you think that your n is bigger and you would have large number of possible ways. But make sure that you show your solution so we would know if you have understood it well or how did you solve it. And the third one is permutations of n objects or distinguishable objects. Here comes those repeated characters, like in the word mathematics. We have 11 letters on it. We got 2 M's. We got 2 A's. What else? Mathematics. And we have 2 M's two A's, and two T's. Alright, so those are repeated characters in the word mathematics. So you cannot get the permutation of those the same letters or characters, because you wouldn't be able to identify which is the first M, which is the second M. Alright, so that's why we will be using the formula for permutations of distinguishable objects. It's just n factorial over p factorial, q factorial, r factorial. Now what those PQR stands for? Those depends on the number of characters or figures that are being repeated in a set. Since in the word mathematics we got 3 characters that are being repeated, you will be taking the frequency of each letter, then after which take note how many times that those repeated letters came out. Then you get that factorial that will be your PQR. If there are only 2 numbers or 2 letters on the given problems that are being repeated, so that will be p factorial and q factorial only. So it doesn't matter which letter you put it into, as long as you multiply those frequency, factorial of the frequency. Gets? And the last one is permutation of our in a circular manner, or circular permutations, like 6 people sitting around the table, in how many ways can they arrange themselves? Just plain and simple, and minus 1 factorial, because one can stay on the same spot and the rest can be arranged because it's circle. So common sense, it's a circle. So if they move to a different spot and you rotate the table, they will be back on the same position. So you would have to get n minus 1 factorial for circular permutation. Now for the combination, again, the combination we will be using the formula NCR. This means the number of combinations from n objects taken r at a time, which is n factorial over n minus r factorial times r factorial. So what was added there is the r factorial. So if you know your n, if you know your r, just substitute the figures, simplify the expressions, solve. That's now the last part is somehow tricky, because there will be a lot of problems to solve, wherein you will be asked to solve using the formula of the 2. So let's give you a short review. Alright, now let's have a clear example so you will be able to relate how to solve combinations. Let's say, for example, we have a team of 17 softball players. Then these 17 softball players need to choose 3 players to refill the water cooler. So again, a team of 17 softball players needs to choose 3 players to refill the water cooler. This problem requires you to apply combinations. So we will be able to, or we would find out how many possible number of combinations would there be in this particular problem. Take note how many players, softball players, do we have in the problem. We got 17. So your n would be equal to 17, right? And then you would need 3 players out of 17 to refill the jug or the water cooler. So that will be r. Taken r at the time, your r would be 3. Applying the formula of combination, which is the number of possible combination taken r at the time, this denoted by NCR, is equal to n factorial over r factorial times n minus r factorial. Alright, so what are we going to do is we will be substituting these figures here into the formula. Your n factorial would be 17 factorial over your r is 3, so that will be 3 factorial times 17 minus 3 will be 14 factorial. So how you're gonna solve this one? You don't need to count all of this. 17 factorial when expanded, that will give you what? I need to upgrade my whiteboard. So 17 times 16 times 15 times 14 times 14 times 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4. I don't fit on my whiteboard. So but 17 factorial when expanded, that will be, actually you don't need to write everything, because as you can see we have 14 factorial, so we would stop at 14 factorial. So you would have only 17 times 16 times 15. That's it, because 14 factorial, we have here a denominator 14 factorial, so we'll stop there because we will be canceling this one and on the top. So what will be left will be 17 times 16 times 15 over 3 factorial. 3 factorial when expanded, that will give you 3 times 2 times 1. Alright, so 17 times 16, 7 times 6, 42, bring down 2, carry 4, 1 times 6, 6 plus 4, 102. Bring down 17, that will give you 272 times 15. How much? 272 times 15, that will give you 4080. 4080 divided by 3 times 2, 6. 6 times 1 will give you 6. So gonna solve 4080 divided by 6. You will have how much? 680. So you would have 680 possible combinations that you can have out of 17 softball players if you will be choosing 3 among the softball players to refill your water cooler. So again, you only need to substitute these figures here into your formula and then solve. Simplify expression if needed, then you will get your final answer. So this is how to solve your combination problem. Now let's proceed to another example. Alright, now let's have our second example. We're finding the number of possible combinations based on this given problem. So let's say if you have 6 black pens, 4 blue pens, 2 red pens, you would like to know in how many possible ways that you can get 3 black pens, 2 blue pens, and 1 red pen. So as you can see here, we have 3 different kinds in terms of 3 different colors. So we would have 3 solutions before we can get to the final answer for the number of possible combinations wherein we can get 3 out of 6, 2 out of 4, 1 out of 2. So let's start. This is actually an application of fundamental counting principle. If you can still remember that it says there, if there are p ways to do one thing and there are q ways to do another thing, then therefore there are p times q ways to do both things. Since we got 3 different kinds, we will need to multiply all those combinations for each of this kind, then you would have your final answer. So let's start with our first solution. Solution letter A, we will be taking the number of possible combinations for 3 out of 6 black pens. Our formula for combination is n, combination of n objects taking r at a time. So if you know where is your n and your r, then you will be able to substitute the value, which is equal to n factorial over r factorial times n minus r factorial. What is your n? We get a total number of 6 black pens. We will be talking about only for black. So your n is 6, your r is 3. So let's substitute the values. We'll change this one into 6 black pens taking 3 at a time. That will be 6 factorial over your r is 3, that's 3 factorial times 6 minus 3, that will be Actually, you don't need to expand this one up to its last digit, but if you want, we'll have 6 factorial. When expanded, that will be 6 times 5 times 4 times 3 times 2 times 1. Are you following? Then 3 factorial. When expanded, that will be 3 times 2 times 1 times 0. 6 minus 3 will be 3. That is still also in factorial, so that will be 3 times 2 times 1. As you can see here, we got here 3 factorial and 3 factorial above, so we can cancel this one out. What will be left is 6 times 5 times 4. 6 times 5, 30 times 4, that will give you 120 over 3 times 2 is 6 times 1 is 6. So you would have 120 divided by 6 will give you 20. For our first solution, the number of possible combinations of taking 3 black pens out of 6 black pens is 20 possible ways. So we're not done yet. Just follow my solution. Our first combination answer is 20 ways. So we will be doing the same way for the number of possible combinations of taking 2 blue pens out of 4. So your formula would be still the same. You will substitute the values. So our n would be 4, taking 2 at a time. So that will be 4 factorial 2 over 2 factorial times 4 minus 2 factorial, still in factorial. If expanding 4 factorial will be 4 times 3 times 2 times 1. 2 factorial, that will be 2 times 1. 4 minus 2 is 2. That is also still in factorial, so that will be 2 times 1. Expanded. When expanded, so crash this out. What will be left would be 4 times 3 over 2, which will be 12 divided by 2 will give you 6. So we got 6 possible combinations if you would like to take 2 blue pens out of 4 blue pens. So your letter B combination will be 6. Just take note of that because we will be leaving that one as we go along to the final answer. So that will be 6. Now let's proceed to taking the possible number of combinations if you would like to take 1 red pen out of 2 red pens. So we will be following the same rule. Your n will be 2 now. You will take 1, so your r will be 1, so that will be 2 factorial over your r is 1 factorial. 2 minus 1 factorial, so 2 factorial when expanded, that will be 2 times 1, right? 1 factorial, still 1. 2 minus 1 is still 1. This is still 1. Cancel this one. What you will have is 2 divided by 1, which will give you 2. So the number of possible ways, possible combinations wherein you could get 1 red pen out of 2 red pens is 2. Of course, there are 2 pens. So it's possible you get the first and you get the second one. So there are 2. So to sum up, our combinations for taking 3 black pens out of 6 black pens, it gives us 20 ways. Our possible combinations of taking 2 blue pens out of 4 blue pens, it gave us 6 ways. And possible number of combinations taking 1 red pen out of 2 red pens is 2 ways. So we would like to find out the number of possible combinations wherein you will be able to get 3 black pens, 2 blue pens, 1 red pen as a whole out of 6 black pens, 4 blue pens, and 2 red pens. So all you have to do is multiply 20 times 6 times 2. So that will be 20 times 6, 120 times 2 will give you 240 possible ways. This is the total number of combinations of taking this one from the given. So now you already have the answer. That's what you're going to do. It's just plain and simple. It's just that this is very long. So you might be confused. What does it mean of combinations? How do you differentiate combinations from permutations or permutations from combinations? Actually, it's not that difficult. So all you have to do is just remember, you might be thinking that permutation sounds tricky or complicated, doesn't it? Because the order matters in permutation, so that's what makes it complicated. Like for example, you would like to take the number of possible ways wherein you can arrange Alice, Charlie, and Bob. It is different than Bob, Charlie, and Alice, but in combination it doesn't matter. You can interchange the person because it will be the order doesn't matter. So that's why we got 4 formulas depending on what is being asked. So all you have to do, just take note and understand the problem. Take note of the clue words. Let's say for example, just remember that permutation, it refers to the arrangement of outcomes or elements or objects in which the order does matter. While the combination, it refers to the group of objects or outcomes in which the order doesn't matter. So it's the opposite. Wherein the formula for permutation, taking n objects taking r at a time, will be NPR, so that's n factorial over n minus r factorial. While in combination, it's NCR, or taking combinations of n objects taking r at a time, is n factorial over r factorial times n minus r factorial. All you have to do is just remember what permutations and combinations means. Alright, so if the order matters, that's permutation. If the order doesn't matter, that's combination. What are those example problems that involves permutation? Let's say for example, any type of race with rank, playlist with order on the shelf, students government like president, vice president, secretary, treasurer, etc. Arranging people, digits, numbers, alphabets, letters, colors, that's permutation as well. Picking a team captain, pitcher, shortstop from a group, that's permutation as well. Picking 3 favorite colors in order from a color brochure. Picking first, second, third, fourth, and fifth place winners, that's also permutations. What about those sample problems that involves combinations? We got people sitting in a car, handshakes or high fives with classmates or teammates, student senators selecting menu. That's my first introduction for illustrating combinations, if you can remember. Selecting food, clothes, subjects, even team. Picking 3 colors from a color brochure wherein the order doesn't matter. Picking 3 team members from a group. Selecting 6-digit numbers out of 45. So the order doesn't matter. Those are just examples of the sample problems that requires combination. So I hope that you have learned a lot from this short review from Milk 1 module up to Milk 5, and I hope that you were able to get a perfect score for my summative test that involves permutations and combination. So that's it. I hope you find it very easy. Just understand the problem, remember the clue words, and you're good to go. Thank you so much for watching, and stay safe and have a great day. So once again, this is your teacher friend Liz saying goodbye.